Hey, this is Mr. Coker with Algebra Lesson 2-3, Finding Characteristics of Quadratic Graphs. What I'm going to talk about in this video is finding the following characteristics. Vertex, minimum and maximum, or minimum or maximum, x-intercept, y-intercept, domain, range, excess of symmetry, and interval of increase and interval of decrease. So I'm going to use these two graphs as my examples. So to begin with, the vertex. Now, the previous videos that I've made dealt with finding the vertex because they dealt with graphing quadratics. So hopefully you know how to find the vertex and what the vertex is. The vertex is the midpoint of a graph. It's the one point that's kind of the beginning of the graph, the middle point, one single point of the graph. And we talked about how to graph it, and hopefully you know how to plot it. But if you're given a graph, you can look at this point and you have to determine what the point is. Well, this point is on 0 and -1. So on the x-axis it's at 0, the y-axis it's at -1. So our vertex is 0 and -1. Next I'm going to do the minimum and maximum. First thing to point out, anytime that we have a graph that's positive and is going up, so this graph is going up, that has, notice it has a lowest point. So these arrows are pointing up to say that it's going and going and going up. That means that there's a lowest point of the graph. Notice at -1, there's nothing below that that's part of this graph. So the minimum in this case is -1. And of course there is no maximum because these arrows mean that it goes up to infinity. Now the x-intercept. Now the x-intercept, that is, we'll talk about how to find x-intercepts from equations quite a bit. I'll talk about finding it by factoring and then with a quadratic formula. But with x-intercepts, this means where it crosses the x-axis. It's also known as the solutions of the graph, or the roots of the graph, or the zeros of the graph. But when we have the actual graph, we can look at it and we can see exactly what the x-intercepts are. Notice it crosses, in this case, at -1 and at +1. And that's important that we have two of them. Oftentimes with quadratics we'll have two x-intercepts. Well, the y-intercept, we're always going to have one y-intercept on a quadratic. And in this case, we can look at the y-axis and, well, it's still -1. -1 because that's where it crosses. So far, everything's pretty easy. Hopefully seems simple. It gets a little bit, with the domain and range, they're not difficult, but there's a lot to remember. So the domain of any quadratic graph where you've got these arrows pointing up, remember that it's not only going up, it's going outward, ever so slightly in this case, but it's going outward. And if you put it in a graphing calculator and you zoom out repeatedly, you'll see what I mean. It goes on and on and on and on and on. And the reason, and because of that, the domain, there's no stopping the domain, not just going up, not just stopping a graph going up, but stopping it going on either side. The domain is the list of x values for a graph, And in this case, the x values keep going to the left and to the right, so the domain is all real numbers. So all real numbers. Next is range. Range is the list of y values. So if you have the list of y values, we can look at this and we can say, what? Look up at the top of the graph. Do you see the y values ever stopping? Hopefully you don't, because they don't. They'll just keep going. You'll get higher and higher numbers. But on the bottom of the graph, it stops at -1. Our minimum stops at -1. Because it's going up, we're going to say that the graph, and the range is y is greater than or equal, because it can be equal to -1. And the reason, again, y can equal -1, as we see right here, it can be more, it can be greater than -1. However, it cannot be less than -1. Next is the excess of symmetry. Hopefully you remember, you know the term axis on a graph from y-axis and x-axis. Well, the excess of symmetry is the imaginary, typically imaginary line going straight down the middle of the graph. And it could be anywhere on the graph, but in this case, I'm trying to make the graph fit in my limited position and make the intercepts easy to identify. So I put it, the axis of symmetry, if you notice, is right down the middle of the graph, where x equals 0. Hopefully you can realize that that's the same number of the x value of the vertex. The vertex, the x value is 0, therefore the axis of symmetry is 0. Now the last thing that we have for this graph, intervals of increase and decrease. The interval of increase is any point where as x gets bigger, y gets bigger. This is related to in behavior, which we'll talk about later in a future unit. Or similar to in behavior. So in this case, notice again at the axis of symmetry, 0, x equals 0. At this point, everything bigger than 0, as x gets bigger, y gets bigger. So the interval of increase is any point where x is greater than 0. Well, if the interval of increase is x is greater than 0, then the interval of decrease is everything before x gets to 0. So as x is getting bigger, going to further right, y is getting smaller up until x equals 0. That means the interval of decrease is x is less than 0. I totally get that a lot of this stuff seems repetitive, and it seems like it just has some minor differences in signs, whether it's greater than or equal to, equal, greater than, less than. We see everything here. But and a lot of numbers repeating. So I'm going to, and make sure you get an opportunity, if you need to write this down, go ahead. I'm going to switch now from this graph, the positive graph, to the negative graph. But I'm going to go position by position. I'm only going to, I'll talk about each one and only change the ones that need changing. So from here on, we're going to talk about graph 2. This negative graph. Notice it goes down. That is a negative graph because it points down. The vertex, I'll put the vertex in the same spot just to show kind of for a point here. It's the same equation, just flipped. It's actually x. This one is x squared minus 1, and this one is negative x squared minus 1. I didn't list the equation because we only worry about the graph here. So a vertex is the same on each one. The minimum and maximum. Well, notice the first graph, of course, had a minimum, but this one, does it have a highest point or a lowest point? Hopefully you notice it has a high point. There's nothing above negative 1, and it keeps going down, which means in this case we have a maximum of negative 1, not a minimum. So any positive graph has a minimum, any negative graph has a maximum. Okay, x-intercepts. Where does it cross the x-axis? Trick question. It doesn't. Notice the x-intercepts. It does not touch the x-axis. When we do solving, this is going to be what we call no solution. X-axis, I'm just going to put none because it doesn't touch the x-axis. It would, again, it's what we would call no solution. Now the y-intercept is going to be the same. That's not changing because it still crosses at negative 1. Typically you can find the y-intercept by looking at the graph, but sometimes you have to use the basic pattern and just expand the basic pattern. And you have to think not just 1, 2, 1, 2, 4 that we talked about previously, but also up 3 or over 3 up 9, over 4 up 16, up 5 up 25, whatever. Domain is still all real numbers. Whether it's positive or negative, the domain of a quadratic is always all real numbers. Unless there's some reason, unless we have a restriction of domain restriction of some sort, which we will not in this class. The range says y is, in the first, originally it said y is greater than or equal to negative 1. Well, if when it was going up, it was greater than. So if it's going down, we're going to change that and make that less than. Excess of symmetry. Again, that's the middle point of the graph, and it's the x value of the vertex. Well, remember, we didn't change the vertex, so we're not changing the excess of symmetry. The excess of symmetry is an imaginary line. If we made an imaginary line down the graph, down the middle of the graph that goes through the vertex, that would be the excess of symmetry. And it is at 0. Now, interval of increase and decrease. Originally, we said interval of increase was everything where x is greater than 0, and decrease was everything x is less than 0. So when x is less than 0, it's going down. Well, now we flipped the graph. We've literally flipped it. So we're going to flip the increase and decrease. So again, we're going to look at the excess, what number is excess of symmetry, and we're going to say, until we reach x equals 0, notice it's going up. This graph is as we go to the right, it's moving up before 0. So when it's less than 0, it's increasing, and when it's as we go further past 0, greater than 0, it's going down. So these are some of the characteristics of quadratic graphs. That's all I'm getting into in this video. You could find other You know, you can find a lot of information. This is what I want to talk about in this class. So, um, take a look at it. Pause it if you need to, because this video is over.